We know about simple harmonic motion from 11th class, right? What is a simple harmonic motion? Suppose if I have a system in stable equilibrium, right? What is stable equilibrium? Suppose I have a bowl, okay, and in this bowl there is a ball, okay, or a marble. Now this marble is in stable equilibrium, right? So if I displace it by smaller amount x in this anyways, okay, then what will happen? It will again come back to the same position, right? So this is a stable equilibrium example. In unstable equilibrium, what happens? Suppose a bowl is kept inverted like this, and if I keep a marble over here and if I displace it by a small amount here, it will not come back again to that point. So in the case of stable equilibrium, you will get SHM, simple harmonic motion. Now what is simple harmonic motion, to be precise? So simple harmonic motion of a particle means your to and fro motion, okay, that we understand. It is a to and fro motion. Everybody understands that simple harmonic motion is to and fro motion like this. But the thing is, suppose if I take an example of a spring and a block system, right? This is one of the example. This is mass m and it is kept on a frictionless surface. If I displace this block by a certain amount x, very small amount x displacement, now in this case what will happen? Spring will get stretched, and as a result the spring will try to take the block towards itself. It will try to pull it towards itself, right? Okay, or towards the wall, you can say. So in that case the force is in this direction, right? Now if I press this block in this direction by a certain amount x, again a small amount x, this spring will push the block in the opposite direction, right? In this direction. So you can see always that force is in opposite direction of the displacement, right? Okay, now from here we know that F is directly proportional to the minus x displacement, right? So the direction of the force is opposite to that of the displacement and the proportionality constant is k, and we write this equation like this. The systems which follow this force law are simple harmonic motion system. They do simple harmonic motion, right? And if you write this as ma, because you know according to Newton's second law, F is equal to ma, this is equal to minus kx. So A is equal to minus k by m into x, right? And k by m is nothing but omega square, okay? So I'm not going into the details of this simple harmonic motion, but you just remember this much itself. If you remember that k by m is omega square and F is equal to minus kx, then that is enough for you to do the questions on SHM in electrostatics, right? So let's begin with the first question, okay? Let's begin with the first question, which was asked in JEE mains, right? Let's look at that question. We have two charges, okay? There is one charge and there is another charge. This is capital Q charge and this is capital Q charge, and they are separated by a distance 2a. They are separated by a distance 2a, and there is a charge which is Q0 kept over here. Q0 charge kept over here in the middle part, right? So that means this distance is a and this distance is also a. Now what they are saying is that it has a mass m, okay? It has a charge Q0 and mass m. What they are saying is that if we displace this Q0 from this position, by the way, both of these are positive charges, okay? Both of these are positive charges. This can be positive or negative. The story will be same, okay? So let's assume it is positive, correct? Okay. So what they are saying is that they are displacing this Q0 in one of the direction. Let's say in this direction they displace by amount x, and now they are saying this, when we displace this by small amount x in this direction, it starts performing simple harmonic motion, and they are asking what is the time period of that simple harmonic motion, okay? If you find out omega, you can find out the frequency, no issues. Now if I displace this in this direction by x amount, then this particular particle will come over here, right? Now what are the forces acting on this? See, because of the right charge over here, the force on this will be in this direction, okay? So yeah, if I'm drawing this charge over here again, q0. Due to this charge, capital Q, the force will be in the left direction. Let's call that force as F2. I will call this charge as 1, this charge as 2, right? This force is F2. Now this guy, the plus Q charge over here, will again repel this in this right direction, right? But now that force will not be that much, because here the distance between Q0, this is the new position of Q0, right? At this point we are finding out the force, right? So this distance between Q0 and Q is nothing but A minus X, right? And this distance between Q0 and capital Q is A plus X, right? Okay, so this, because of A plus X distance, the force obviously has to be lesser. So the rightward direction force is lesser than the left one. Okay, so this is more magnitude than this. So F2 is greater than F1. Very good. So that means eventually the force, the net force, will be in this left direction, right? So that means if I displace this in this direction by x amount, the net force is in the left direction, correct? Okay, so if I now displace it in this direction, if I were to displace this Q0 charge in this direction, the force due to this charge would be more because the distance is lesser, and force due to this charge will be lesser because the distance is more. So here in the right direction the force will be greater than the left direction. So in that case, when I displace it by small amount here, the charge would be accelerated towards this point. Okay. Now the force is always pointing at this particular mean point, okay, or midpoint, you can say midpoint. So now the force is a restoring force. I can see from here, this is a restoring force, correct? Okay, but now this force has to be directly proportional to x. Then we can find the omega and in turn the time period, right? So let's see if it is written in terms of directly proportional to x. Okay, so let's look at that. If you look at this position of q0, the force due to, again we are talking about this position only, right? Force due to the rightward charge is F2. So can I write it as F2 is equal to kq upon the distance between q and q0. Okay, there will be q0 as well, right? So the distance between capital Q and q0 is a minus x whole square, right? And F1 is of course smaller force. So F1 is equal to k times q into q0 divided by a plus x whole square, correct? So now the net force is equal to F2 minus F1, right? So what is the net force? F2 minus F1, which is kq q0 divided by a minus x whole square minus kq q0 upon a plus x whole square, right? Correct. So now the net force will be kq q0 into 1 upon a minus x whole square minus 1 upon a plus x whole square, right? Okay, let me see if it is visible. Yes, it's visible. Okay, so now the net force I will write over here. The net force is kq q0 into a plus x whole square minus a minus x whole square divided by a minus x whole square into a plus x whole square, right? Okay, so now what we are going to do is, we don't have space, right? Okay, so let's erase this one. So let me erase this one and write over here again. Okay, so this will be F net is equal to, if I expand this, it will be, okay, Q0 is later, we will write it later, no problem. A square plus 2ax plus x square minus a square minus 2ax plus x square divided by a minus x square in whole square into a plus x whole square. So can I write that as this, a minus x into a plus x into a minus x into a plus x. Okay, I am writing it in this fashion, correct? Okay, so now this will become, see, by the way, x square will cancel out with this one, a square will cancel out with this one, and this is 2ax plus 2ax, which is 4ax, right? Okay, I forgot to multiply by kq0. Okay, so I will write it over here, divided by kq0. Okay, our main interest is this. Okay, so F net divided by kq0 is 4ax in numerator. This is a square minus x square into a square minus x square, this to the power 2, right? This to the power 2. Okay, now what I am going to do is that I am going to take x square outside. Okay, I am going to take x square outside. It's very small, so I can take it outside. So it's not like that, I will just tell you. I want to take x square outside. Oh, sorry, not x square outside, sorry. I want to take a square outside, not x square. Sorry for that. I want to take a square outside. So if I take a square common from here, it will be 1 minus x square by a square to the power square 2, right? Okay, so now this will become 4ax divided by a to the power 4 into 1 minus x square by a square to the power 2. Now, what we are going to do here? See, x by a is very small, right? If x by a is very small, then x square by a square is very small again, right? If your x by a is very small, that means it is 0.000001, and if I square it again you will get more number of zeros, so that is very small, right? Very small than 1. Compared to 1, this ratio of x square by a square is very small. So that means we are going to neglect this, right? So this will be 4ax divided by a to the power 4. This is going to be 0, and hence we are getting this multiplied with kq0. This is your F net, right? Okay, so you got this answer, and this you can cancel it, it will become aq here in the denominator. So I think you can see, yeah. So your F net is equal to 4kq0 x divided by aq. Now you can see the force is directly proportional to the displacement over here, x. So that means this is nothing but your spring constant. Now here already k is there, we will call that spring constant as k dash. Now if I write this as k dash by m, then I will get omega square. So omega square is nothing but this k dash by m, 4kq0 divided by maq. So omega is nothing but square root of 4 upon 4 pi epsilon naught q0 maq, right? Now you can cancel out this 4 here. And now what is the time period as asked in the question? So the time period will be 2 pi by t is omega. So this is equal to square root of q0 divided by pi m epsilon naught aq, right? So the time period t is equal to 2 pi root of pi m epsilon naught a cube upon q0, right? Okay, so now we will take this inside and let's say what it turns out to be. Correct. The time period t turns out to be, if I take it inside, it will be square root of 4 pi cube, because it will become pi square once it enters inside the square root. So this is m epsilon naught a cube by q into q naught. This is going to be the time period of this particular charge q0 doing SHM 2 and 4th, right? Okay, so let's look at the next question.